Hello students, again I am here with your favorite channel Ryan Tutorials. Okay, so today we are going to do a chapter of class 10, both very important in ICSE as well as CBSE. The chapter is of chemistry, it's acid, base and salt. Now the salt I will do it in the next video. In this video we will be studying only of acid and base. Okay. So first let us know what is acid. What is an acid? What is an acid? Just remember one thing. This acid, it's nothing but it displaces hydrogen ion. Acid, what is an acid? It displaces hydrogen ion. Okay. Now this hydrogen ion, it's a very unstable. It's very unstable. It's always electropositive. It's what to say, like it's a charged ion, and this acid is always in aqueous solution. So acid in aqueous solution, whenever you mix water with acid, means the aqueous solution, it will displace the hydrogen ion. Now this hydrogen ion, as I told you, is very unstable. So what it does, it reacts with water. It readily reacts with water and gives here H and H2, that means H3O. Now this is called, this is called hydronium ion. Clear? So what does acid displace? Hydrogen ion. But you can't find the hydrogen ion. Why? Because hydrogen ion is very unstable. So it readily reacts with water. From where does the water you get? It's an aqueous solution, right? I told you the acid aqueous solution displaces hydrogen ion. Means what? You see, whatever acid you just mixed it with water, then the acid contains hydrogen, it will displace that hydrogen ion. It will give away that hydrogen ion and form hydronium ions. Is that clear to you? Okay. Now, what are the different types of acids? Acids we can get organic acid. Organic acid. What is organic acid? Organic acids are, I first write down, okay? Organic acid, mineral acid, strong acid, and weak acid. So organic acid, mineral acid, strong acid and weak acid. Now organic acid, what? Organic acid means which we get from living organisms like plants, like animals. Like suppose I say formic acid. I say formic acid. Formic acid, from where do we get this formic acid? We get it, the sting of the ant. It's a formic acid. Then you can say tartaric acid. Tartaric acid. From where do we get tartaric acid? From tamarind tree. The one with imli, the tamarind. Okay. Then the lactic acid. We get lactic acid. Lactic acid we get it in the sour milk. Then the citric acid, somebody can say citric or citric acid, whatever you pronounce, it's okay. We get in the sour fruits like lemon, then what's that called? Lemon, any sour fruit. The raw mango, it's all citric acid. So formic acid, then vinegar, we get vinegar, CH3COOH, we get it in vinegar. Then what else we get? These all are the organic acids. Now always remember, these organic acids are all weak acids. The organic acids are all weak acids, and the mineral acids are all strong acids. Now what is weak and what is strong? Wait, I discuss. So mineral acids we get from the earth, from the minerals. Whatever minerals, the acid we get like iron, ferrous, then zinc, then magnesium, then chlorine, all these are minerals. So we can say mainly in your syllabus you get HCl, you get H2SO4, sulfuric acid, you get HNO3. These all are mineral acids. Now mineral acids are all very strong. In your syllabus, you got HCl, you got H2SO4, you got HNO3. Apart from this, there is carbonic acid, H2CO3, there is H3PO4, phosphoric acid, H3PO4, there is sulfurous acid, this is sulfuric, there is one more called sulfurous, SO3, sulfurous acid, then hydrogen sulfide, all these are mineral acids. Now mineral acids are always strong. Now how can you define which is strong and which is weak? Strong and weak means the more hydrogen ions they will displace, the more stronger the acids will be. And if suppose I say suppose let me say about this one, like vinegar. Say there are 5 molecules of acetic acid. Actually this is the acetic acid, we find it in vinegar. So there are 5 molecules of acetic acid. Clear? Now in these 5 molecules of acetic acid, all the hydrogens, there are 3 and there is 1, 4 hydrogen is there, right? So there should be 4 hydrogen plus ion. Am I right? So when this acetic acid will displace all the hydrogen ions, that means there will be 4 hydrogen ions, but in reality they don't do so. That's why they are weak. Now why they don't do so and why the mineral acids displace all the hydrogen ions, later I will come. So understood what is an acid? Acid in an aqueous solution displaces its hydrogen ions, and this hydrogen ion, as it is very unstable, it readily reacts with the water and forms hydronium ions. Now what are the different types of acids? Organic acid, mineral acid. Organic acids which we get from living organisms, and mineral acids which we get from our earth, from the minerals like formic acid, tartaric acid, lactic acid, vinegar or acetic acid. These are all organic acid. And mineral acid, hydrochloric acid, sulfuric acid, nitric acid, sulfurous acid, hydrogen sulfide, what is that? Carbonic acid, phosphoric acid, all these are mineral acids. Now normally all the organic acids are very weak. Why they are weak? Because they doesn't displace all the hydrogen ions. But the mineral acids, they displaces all the hydrogen ions. Now there is one thing, it's carbonic acid. Remember this one, carbonic acid. It's a mineral acid, but it's not a strong acid. It's a weak acid. So many a times in ICSE I saw a question coming, name a weak mineral acid. So the answer will be carbonic acid. Clear? Note it down. Today there are a lot of things you need to note it down. Okay? Okay. So now let us discuss why an acid becomes strong and why an acid becomes weak. Okay, so from where should I start? See, which one is called a strong acid? When we should say it's a strong acid. Say strong. When all the what should I say, molecules, all the molecules will furnish hydrogen ions. Clear? So when all the molecules will furnish hydrogen ions, then we can say that it's a strong acid. And weak acid, when all the molecules will not furnish the hydrogen ions. Clear? Okay. Now that means you see, in an acid there is a like what to say, like there is a number of ionizable hydrogen ions. That means this one we can say these are the numbers of ionizable hydrogen ions, right? Means all the hydrogen ions are not replaced. In weak acid it's not replaced, in strong acid it's replaced. That means we can find out the number of ionizable hydrogen ions, and this number of ionizable hydrogen ions is known as basicity of an acid. So if anybody asks you, if the question comes, what is the basicity of an of an acid? The basicity of an acid is the number of ionizable hydrogen ions present in the acid. Now that means what? That means suppose H2SO. How many hydrogens are there? 2. But you cannot just simply write 2 basicity. You have to see out of these 2 hydrogen ions, how many are ionizing, how many are displacing the hydrogen ions. Clear? I give you with some examples. Suppose HCl, then H2SO4. First I write HNO3. HCl, then HNO3, then H2SO4, what else? HCl, H2SO3, H2SO3, H3PO4, phosphoric acid, H3PO, 3 also can, phosphorus acid, and H3PO4, phosphoric acid. No, let me write this one here, H3PO3, H3PO4. Okay, here I write what else? Carbonic acid, H2CO3. And here let me write, say, acetic acid, CH3COOH, then HCOOH, formic acid, then H3PO4, H3PO3. Okay, now if I ask you what is the basicity, see here one hydrogen, so here there will be one hydrogen plus ion. That means number of ionizable hydrogen ion is 1. So the basicity of HCl is 1, and we can call this as monobasic. Monobasic, because only one ion is displacing. This is also hydrogen 1 plus, this is also same. This is hydrogen 2, that means it will be giving you 2 hydrogen plus ions. So basicity is 2. That means this is called dibasic. Dibasic. Now this one is H2SO3. This is also 2. So this is also dibasic. H2CO3. 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 This is also dibasic. Clear? So monobasic, dibasic, sometimes you will get tribasic also. So this is the basicity of an acid. Now you see here very easily I find it out, right? H1, that means 1, H2, so 2, H2, so 2. But here you see H here 3, here 1. So what should I write here? What should I write here? H4, right? No. Here should be H plus only. Clear? Now HCOOH. Here what should I write? How many hydrogens are there? 2, 1, 1. But here also 1. H3PO4. H3PO4. How many hydrogens are there? 3. Okay, this is right. 3 hydrogen. This is tribasic. But here H3PO3, here we cannot write 3, here it will be 2, because it is dibasic. Now see, here we got 4 hydrogens, but only 1 hydrogen is displaced. Here there are 2 hydrogens, but only we are getting 1 hydrogen ion. Here there are 3 hydrogens, we are getting 3 hydrogen ions. Here 3 hydrogens, but we are getting only 2 hydrogen ions. Why? Why? Let me show you why. Always remember, only those hydrogen atoms, or sorry, only those hydrogen gets displaced which are attached to the oxygen. Like here there is hydrogen, you have to know the structure of the compounds. This structure, this is the organic chemistry chapter, and you will be learning this chapter in class 10 itself, but after some days or after some months. I just show you like say suppose I do first, which one should I do? Let me do okay, I do this one first. H3PO4, okay? H3PO4. See, here the basicity is 3. Why you know? Because here the structure is this is the structure, or better I write it like this. If P I didn't write. Now see, H3PO4. Clear? This is the structure of H3PO4 or phosphoric acid. Now you see here this hydrogen is attached with oxygen atom. This hydrogen is attached with oxygen atom. This hydrogen is attached with oxygen atom. That means there are 3 hydrogen attached with oxygen atoms. So there will be 3 hydrogen ions. Why? Because oxygen is always electronegative. What it will do? It will what to say? It will pull one electron from hydrogen, and this hydrogen will become positive. Clear? Because oxygen is always electronegative. So H3PO4 is tribasic. Why? Because it is displacing 3 hydrogen atoms. Clear? Okay, now let us see which one should we see. We have seen this one, right? Now let us see this one. CH3 COOH. CH3 COOH. Okay? Now this is like this. H3 CH3 COO CH3 CH3 COOH CH3 COOH. These are called the structural formula. Okay, now see here. First let me check whether I have written it right or not. CH3 COOH. Okay. Now see here, this hydrogen is not attached with oxygen. This hydrogen is not attached with oxygen. These are the bonds. These are the bonds. This is the double bond. These are the single bonds. This hydrogen is not attached with the oxygen. Only this hydrogen is attached with oxygen. That means here only one hydrogen is attached with oxygen. So we will be getting only one hydrogen, displaceable hydrogen. That's why the basicity of CH3 COOH is 1. Clear? Note it down. You have to do it in this very class only. And in class 11 and 12, all you have to do like this. Okay, next let us do this one. Okay, HCOOH. Am I right? Yes, I think I'm right. HCOOH. Now see here. Here we got two hydrogens, right? Here we got two hydrogens. One this, one this. Now this one is linked up with carbon, so it will not displace hydrogen ion. This one is linked up with oxygen, so here we will be getting only one hydrogen ion. That's why it is 1. Clear? Now let us see this one. H3PO3, phosphorus acid. Phosphorus acid. H3PO3. H3, right? H3PO3. Double bond here. H. 3H are there, right? So H. Now it's okay. H3PO3. This is the structure of phosphorus acid, H3PO3. Now here also you see this hydrogen is not linked up with oxygen. Only this one and this one is linked up. So it will be giving 2 hydrogen ions. So this is the basicity 2. Clear? Understood or not, everybody? Note it down. First chapter. Okay. Clear? Can I repeat? Okay. Okay, now how should we prepare the acid? Preparation. How to prepare acid? First of all, always remember acids we will be getting all from non-metals, and from metals we will be getting base. Now what is base? Later I will come to you. Now just think or remember one thing, that acid acid you will get from non-metals. Clear? So non-metals plus hydrogen gives acid. Remember this one. Non-metals plus hydrogen gives acid. Clear? This one you can also say direct combination or direct synthesis. This is also known as direct combination or synthesis. Non-metals plus hydrogen gives you acid. So name some non-metals like chlorine, bromine. Okay, chlorine, bromine, what else? Let's do this two only. Suppose hydrogen, and hydrogen it will give you HCl. Balance 2. This will give you hydrogen bromide. Clear? Again sulfide, like sulfur plus hydrogen, hydrogen sulfide. So number 1 you got it. Preparation is non-metals plus hydrogen gives you acid. Clear? Okay. Next. Preparation. This is number 1. Number 2. non-metal oxides, non-metal oxides plus water will give you acid. So non-metals, if you add up non-metals with hydrogen, you will get acid. And for non-metal oxides, if you add with water, you will get acid. For example, let's take carbon dioxide. Carbon dioxide plus water will give you carbonic acid, right? Now what is metal oxide? Non-metallic oxide means non-metal mixed with oxygen. Like carbon is a non-metal mixed with oxygen becomes carbon dioxide. So carbon dioxide is a non-metallic oxide. Similarly, if I say sulfuric acid, clear? SO3, sulfur, it's a non-metal, mixes up with oxygen or reacts with oxygen. That means oxide of an oxygen is SO3 plus water gives you sulfuric acid. Clear? Okay. Next. So metal, direct non-metal plus hydrogen, non-metallic oxide plus hydrogen, then oxidation of non-metal. Oxidation of non-metal, oxidation of non-metal. Always remember, as I told you, acid always non-metal, base always metal. Oxidation of non-metal, say 2-3 non-metals like what should you say? Sulfur. Just now we took carbon, phosphorus. Now you have to oxidize it, right? You have to oxidize it. Always remember HNO3. Where should I write? Let me write here. HNO3, strong oxidizing agent. Okay, so always remember HNO3 is a strong oxidizing agent. Now oxidization of non-metal, that is sulfur, just oxidize it, put it HNO3. Now what we will get? We will get an acid. Which acid should we get? Here we will get H2SO4. Here you give HNO3. What acid we will get? We will get H3 carbonic acid. Here you put HNO3. What we will get? We will get phosphoric acid. Clear? So sulfur oxidizing with nitric acid, we get sulfuric acid, carbon, carbonic acid, phosphorus, phosphoric acid. Yes, we will be getting some byproducts. What are the byproducts? The byproducts will be water and nitrogen oxide. Water plus N2. Water plus N2. Clear? Understood? Now balance the equation. Balancing, let me give you a trick. See, for ICSE syllabus, only these three are main. Okay. Now I give you a trick for the balancing. sulfur, carbon, phosphorus. Sulfur, carbon, phosphorus. Do one thing. Write this carbon down. Okay, always remember like this: sulfur, phosphorus, carbon. Why? I tell you. Carbon plus HNO3 gives you H2CO3 plus H2O plus N2O. Okay, now put here 6, put here 5, put here 4. You will be getting balanced. These three are only in your acidity levels. So here are 6 nitrogen. Here put 3. So put okay. So here is 6 nitrogen. That means 6 nitrogen. So here you put 6. Clear? Here there are 5 nitrogen here. Oh, I made a mistake here. Not N2. These all will be NO2. These all will be NO2. NO2. Here is 5. Put here 5. Here is 4. Put here 4. Now the balance is 6 hydrogen. 2, 2, 4. Put here 2. 6 hydrogen. 6 nitrogen, 6 and 3, 18 oxygen, 4, 6 to 12, 12 and 4, 16 and 2, 18. You see, it got balanced. Clear? So oxidation of non-metal. Just remember these 3 only. That's all, don't worry. I tell you. Okay. Here see the balancing: 5 nitrogen, 5 nitrogen, 5 hydrogen, 3 hydrogen and 2 hydrogen, 5 hydrogen. 5 and 3, 15 oxygen, here 4, here 1, 5, and here 10, 15, see, got balanced. See, 4 nitrogen, 4 nitrogen, 4 hydrogen, 2 and 2, 4 hydrogen, 4 3 is a 12 oxygen, 3, 4, 4 2 is 8, 12 oxygen. All got balanced. So 6, 5, 4, 6, 5, 4. Clear? Understood? And always remember, HNO3 is a strong oxidizing agent. Many a times question comes, name a strong oxidizing agent. Just close your eyes and write HNO3. Is that clear? Okay. Now what else? So oxidation of non-metal finished. Oxidation of non-metal finished. What else? Okay. One more thing. From salt. From obviously mineral salt. Always remember salt plus non-volatile acid gives you volatile acid. Salt plus non-volatile acid will always give you volatile acid. Clear? And also remember that HNO3 and HCl, these are 2 volatile acids, and H2SO4 is a non-volatile acid. Now what is volatile and what is non-volatile? I hope you know, right? Like if you put it in the air, it will evaporate. That is volatile. And non-volatile, it won't evaporate. And in your syllabus, only these 3 acids are there: nitric acid, hydrochloric acid, sulfuric acid. So just react anything. Say suppose you want to get nitric acid. Okay, you want to get nitric acid. So you want to get nitric acid. So you have to take a non-volatile acid. So take here H2SO4. Now you have to bring a salt. Whose salt? Here it is nitrate. That means some nitrate salt you need. So what nitrate salt? You just put here sodium nitrate. Or you can also put here potassium nitrate. Clear? So sodium nitrate plus sulfuric acid gives you nitric acid plus sodium hydrogen sulfate or sodium bisulfate. What happens? See HNO3, this one H and NO3 combines together. So one more H is left and here NaSO4 is left. So NaHSO4. If it is potassium nitrate, then this one will be nitric acid, this one will be only K. Clear? Okay. Now suppose if you want to get HCl. Suppose you want to get HCl. Fine. Here you react with sulfuric acid. So here it is chlorine, right? So chlorine you just put sodium chloride, or you can also take potassium chloride. So what will you get? You will get hydrogen chloride plus, see, one hydrogen and one chlorine gone. So remaining what? Sodium hydrogen sulfide. So NaHSO4 or KHSO4. Clear? So non-metals plus hydrogen, non-metallic oxides, oxidation of non-metals from salt. Anything else? I don't think so. I don't think so. No, it's okay. So this is all about how you will prepare an acid. Okay, next just quickly go through the properties of the acids. What are the main properties of the acid? See, for learning the main properties of the acid, you have to, the activity table, activity series. The activity series you have to learn by heart. And mainly the position of hydrogen. The elements above the hydrogen, they are more active. Lower the hydrogen, they are less active. So you must learn the activity series. Then you must learn the indicators. These indicators, acid and base, I am telling both at a time. Okay. Now what are the indicators? Actually, what is indicator? Suppose I give you a solution. Now how will you know whether it is an acid or it's a base or it's just water? All the colorless milk. So you have to put some indicator. It means you have to dip something or you have to put something so that it indicates what it is. So the main indicators we get are, we get litmus, then we get phenolphthalein, we get methyl orange, we get pH scale, what else? We get universal indicator. All you will get to know when you go to the lab. I don't think in class 10 you are around in the lab. But in class 11, when you will be starting your practicals, you have to use all these things. Litmus, phenolphthalein, methyl orange, pH scale, universal. What else? I think that's all. Okay. So here for acid. Okay, this one let me put for base and this one for acid. Acid is a dangerous thing, right? You have heard that many have committed suicide by drinking acid. Then there are many crimes like throwing acid balls to somebody's face or like that, right? If by accident also it happens to fall the acid on your hand in the lab, your hand will get burned. So acid is very dangerous. Now what is the alert sign, danger sign for acid? It's red, right? So for litmus, acid becomes red. Methyl orange, acid becomes red. Universal, acid becomes red. Easy to remember? Okay. For phenolphthalein, acid becomes colorless. Colorless. And for pH scale acid is always less than 7. Always less than 7. Means it will be 6, 5, 4, 3, 2, 1. Clear? And more it will go downwards, the more stronger acids. That means the one whose pH scale is 3 to 1, they are very strong acids. And the one which are 6, 5, 4, these are weak acids. Is that clear? Okay. Now universal is red. Actually the universal it is, I tell you the thing, it is wave gear. Okay. Now for wave gear, which is in the middle, green, right? So this is neutral. This one is acid and this one is base. Means orange, yellow, orange, red. If it is yellow, it's a weak acid. Orange, a bit stronger acid, and red, strong acid. Similarly, if it is blue, very weak base. Indigo, a bit stronger base, and violet, strong base. Clear? Okay. Next. Okay. Phenolphthalein, it becomes pink. Methyl orange, it becomes yellow. Or litmus, it becomes blue. pH scale, it becomes always greater than 7. Similarly, the more the value, it will be more stronger base. And universal, it's violet, but actually even it is indigo or blue, you can call the substance, you can call the chemical as base. Clear everybody? Okay, so again let me remind you, don't forget to memorize the activity series. Clear? The activity table. Okay, what else is there? Preparation finished, properties more or less told. What else? Okay, for properties there are some things like maximum dilute mineral acids. In your syllabus, maximum places you will see dilute mineral acid. This is very important, okay? So dilute mineral acid, first thing what you can say, dilute mineral acid reacts with, this one you can say, dilute mineral acid reacts with the elements above the activity series, okay, with elements above the hydrogen in the activity series to evolve hydrogen. Clear? Understood? So dilute mineral acid reacts with elements above the hydrogen series to evolve hydrogen. Now dilute mineral acid, which one is dilute mineral acid? Sulfuric acid, hydrochloric acid. Okay, sulfuric acid is also a dilute mineral acid. It's a mineral acid, put water it will be. So it says that it evolves hydrogen. It evolves hydrogen. When reacts with elements above the hydrogen table. Why all my pen is falling down today? Just okay, so above the hydrogen table, what is there? Above the hydrogen table, magnesium is there, iron is there. So what will happen? Here hydrogen comes out, so it becomes FeCl2. Or you can do like this also. Okay, here hydrogen evolves also NGCl. Clear? Okay. What else? Metals. What will happen to metals? So this is one. Then properties. So from here you can see one thing, like metals above the activity series will always evolve hydrogen. Then there is one reaction with metal carbonate. There is a reaction with metal carbonate. Metal carbonate plus acid will always give you carbon dioxide plus this is means water plus salt. Clear? So any metal carbonate reacts with acids to give you carbon dioxide, water and salt. Now neighboring metal carbonate say suppose zinc. Zinc is a metal, so carbonate means CO3. Zinc carbonate, something else. Let's say magnesium, MgCO3. Okay. Now acid, say suppose H2SO4. Here let me take suppose HCl. Now what it will be? Carbon dioxide. So carbon dioxide will evolve plus water will evolve plus later I am coming. Here also carbon dioxide will evolve. See, this is how you have to remember the equations. Understood? Now see, we know from the properties of acid that acid reacts with metal carbonate to form carbon dioxide, water and salt. Now zinc carbonate, plus sulfuric hydrochloric acid, carbon dioxide and water will 100% come out. Okay, so carbon dioxide came out, water came out, remaining is ZnCl. So zinc chloride, this is the salt it will form. Here carbon dioxide came out, water came out, so MgSO4. So this is the salt they will make. Now balance the equation. Hope you know how to balance, right? If not, you go to the channel I am tutorials, just type there balancing chemical equations. You will get many tricks how to balance. Clear? Can I rub it? Okay. So, why did I rub this one? Plus acid, right? Okay, examples I can, yes. Okay. So what else? Okay, metal sulfides. Metal sulfides plus acid. Metal sulfides plus acid, it will give, here they give CO2, here sulfide, so SO2 plus water plus salt. Clear? See the similarities. CO2, SO2, H2O, H2O, salt. Why is that difference? Carbonate, sulfides. Okay. Sulfide. What sulfide should I take? Let's take sodium sulfide. Na2SO3. Na2SO3 or NaSO3? No, Na2SO3, right? Plus, say, suppose HCl. So it will give you SO2 plus water plus, now see salt. Sulfide SO2 came out. Now coming NaHCl, sodium chloride. Clear? What else? Zinc sulfide. Say let's take zinc sulfide plus H2SO4. This gives 100%. These two will remain constant. So zinc and sulfate. So zinc sulfate. Clear? Understood? Suppose, see, the thing is, suppose instead of H2SO4 here, I want to take HCl. Okay, take, no problem. What will happen? Only this zinc sulfate will become zinc chloride, ZnCl. Clear? Metal plus sulfides. Okay, then sulfide. Now let's see what will happen if we react with sulfide instead of sulfides. So metal sulfides plus acid will give you, what it will give you? It will give you hydrogen sulfide plus acid. Salt. Acid I am reacting. Okay, remember this one. So metal sulfides, see this is sulfide, this is sulfide plus acids will give you hydrogen sulfide plus salt. Name, say let me take the previous one only, Zn. Metal sulfide, so ZnS plus what you want to react? Let's say HCl only. HCl will give you H2S, so H2S comes out HSZnCl plus ZnCl. Clear? If I say iron sulfide FeS plus HCl, hydrogen sulfide will come out plus this two came out FeCl. Clear? So you got the reaction with activity series metals, you got the reaction with metals, you got the reaction with metal carbonate, you got the reaction with metal sulfides, you got the reaction with metal sulfides. Now the last reaction, very important reaction, is neutralization reaction. What is neutralization reaction? Very important, very easy, very important. That is neutralization. Always remember, acid plus base gives you salt and water. Very important reaction. That's why if you get burned with acid, there is only one solution: put base. Like sometimes when our stomach gets upset, like we have acidity, what we do? The pink mixture, the medicine which we drink, that is nothing but base. So the base goes in and neutralizes the acid. It becomes water. Clear? What else? I think finished. So this is all about acid, base. What is base? Base is that chemical which reacts with acid to give salt and water. That's it. Like you got basicity of acid, you will be getting basicity of acidity of base. There the base hydrogen ions were displaced in base hydroxyl OH ions will get displaced. The more the number of hydrogen ions, the more will be the acidity of the base. And bases dissolved in water. They got a special name. The bases which can be dissolved in water, they are called alkalis. There is a very common question in CBSE and also in ICSE. All alkalis are base, but all bases are not alkalis. Justify the statement. Very simple. I can say that what to say? I can't remember the example. I hope you understood, right? So all the bases which you can dissolve it into water, they are called alkalis. And there are some bases which are insoluble in water. So that means you are getting the bases in two categories. One is soluble in water and the other is insoluble in water. Clear? Anything I left out? Neutralization, water. Example, you will get it a lot in the book also. Zeleno, then MgO. Okay, these are all insoluble in water. Then what else? Magnesium hydroxide also, MgOH. And soluble in water, sodium hydroxide, then potassium hydroxide, then Na2O, what else? That's all. Clear? Understood? Any doubts? Read the chapter, thoroughly memorize the book. I tell you, chemistry, you have to remember all the equations, and the second thing is equations unbalanced will not give you a single marks. Clear? So you must balance the equations. Syllabus, there is a limitation in your syllabus. Only 3 acids are there: hydrochloric acid, sulfuric acid and nitric acid. And just learn and remember the things which I have taught you. Okay? If any problem, if any doubts, never hesitate to make the question in the comment section. I promise you, I will surely get back to you. Okay? Bye bye.